All right, hi guys. So we are carrying on with investigating quadratic functions in the Vertex form. So this is day 2 of part 3.1 out of the textbook. So to start out with, let's just kind of remember a little bit of what we were looking at last time. So remember we looked at this Vertex form of quadratic functions where we would be able to say y is equal to a times by x minus p squared plus q. Okay, and so we want to try and remember how these different values, the a, the p, and the q, are going to affect the shape of the graph compared to our kind of mother equation, y equals x squared. So we're given a specific equation here, so y equals 2x plus 1 squared minus 3, and we have to answer some questions here. So the first one is, explain how this graph will differ from the mother equation. So remember, the things that are going to make it different are these three values, so we can kind of address them each. So here we see that the a value is positive 2. And what does that tell us? So we might even want to put in that it's a positive 2. So this tells us that, what does the positive tell us? So try and remember. Well, and actually what you might want to do here is maybe go through this first on your own, think about it. Try not to use the drawing that's down here of the graph, but try to actually think it through yourself. And then when you're ready, once you've completed it, you can come back and watch this section and make sure you got it right. So if a is equal to positive 2, then we know that the graph will be narrower than the original graph. Now, because it's positive and y equals x squared is positive, they're still both going to be facing upwards. So because it's not a change, I'm not going to mention that it's pointing upwards. So the graph will just be narrower. Now, what about our p-value? Well, our p-value here is positive 1, but remember that the rule is always that it's going to be x minus our p-value. So if we have plus 1, what that tells us is that our p-value is actually negative 1. And so that means our x-coordinate of vertex moves. So remember that normally for y equals x squared, it's going to be at 0, 0, or the origin. And so if now our x-coordinate is at negative 1, then we're moving our graph to the left. So x-coordinate of vertex moves left to x equals negative 1. Okay, now what about our q value? With our q value, we have negative 3, and this one doesn't really have a change. So because it's plus q, if we have a negative here, that means that our q value is negative 3. And so we can say y-coordinate of vertex moves which way? If we have negative 3, that means we're moving down on the y-axis, so it moves down 3. Or wait, sorry, I should actually just leave it as down, and then we can actually put in the number value the way we did in the previous one. So y equals negative 3. Okay, so basically now we have the points of our vertex, right? Negative 1 and negative 3. And you can see here they've done the graph here, y equals 2x plus 1 minus 3. And we see that the vertex here is at negative 1 and negative 3, with the vertex down and to the left of where x squared would be, which is this main one here, right? Now the next question says, if we wanted to manually graph, so if we want to do it by hand, we're not going to enter it into our graphing calculator, y equals 2x plus 1 squared minus 3, what steps would we use? Well, as we saw in last week's lesson, the first thing we always want to do is to find the vertex. Find and draw vertex. And how do we do that? Well, we use P and Q, using P and Q values. Okay, now what would we do after that? Well, the main things that we need to know after that are the x and y intercepts. So find x and y intercepts. And how did we do that? Well, if you remember last time, we took the points that we knew, so the vertex points, and we put them into the equation to find the intercepts. So using equation. Okay, next one, does the a value affect the x or the y values? And this one is a little bit tricky because if you remember, we talked about how the a value is going to change whether it's narrower or wider, and it's also going to change whether it goes up or down. So you might, because of the narrower or wider, you might be tempted to say that it affects both. However, if you look at the equation here, you can see that if you change a, all that it's going to do is when it multiplies by everything and, calculates out, it's going to change the y value. It does not change the x value. The x value is like interacts with it, but it doesn't actually change because of a. Only y does. So we can say a affects y values. Okay, last question here. What is the vertex of the parabola? Which is kind of what we already said up here when we said x is -1 and y is -3. -1, -3. How is this different from the other graphs? So here they show us two other graphs. So the y equals x squared, which is the mother one, and they give us one other one which just has an a value but no p or q value. And so we know that if we have no p or q value in our equation, then our vertex is always going to be 0, 0, or at the origin, right? So this graph is different because it is different because its vertex is not at the origin. The origin, or 0, 0, right? So this is our main difference when we start having graphs that have p and q values in them, is that the vertex moves. Okay? So that was a little bit of a reminder from last time of some of the stuff we learned. And this time we're going to move forward by just doing some more complicated work with these types of functions. So the first question we're looking at here for determining a quadratic function. So now basically what we're going to be doing is determining the function from the graph. Up until now, we've always tried to figure out what the graph would look like from the function, right? So we're going to work in reverse here. So using our form, like our vertex form, f of x equals a, x minus p squared plus q as our base, what is going to be the most important piece of information about the parabola that we can take to start filling in this equation? Well, we know that like f of x and x are going to be just points on the graph, any points on the graph. A is, it's important, but we can kind of survive without it. The really important thing is figuring out where the vertex is, right? If you don't know where the vertex is, doesn't matter if you know A, you aren't going to know how to place your graph. So the vertex is our most important piece of information. Okay, where is this information found in the equation? Well, we know that P is going to be our x coordinate, and Q is going to be our y coordinate. And so then we can say, if we're trying to find it in the equation, f of x is equal to a x minus p squared plus q. So the places where we can find, let me just see if I can grab a highlighter here. Places where we find this information are at the p and at the q, right? Those are our two pieces of information. What piece of information may be missing? And now you guys might not quite know this yet because I'll show you how this works in the next question, but actually A may be missing. And we can figure it out if we know the other values. Now, even without me showing you that, that's probably obvious, right? Because we can find points on the graph to substitute for y and x. And if we know the vertex, then a would just be the only missing variable that we can solve for. And in fact, that's exactly what we're going to do. So it asks us, how can we find this value? We want to use a point on the graph. Point on the graph to fill in x and y values. Okay, so we can use points that we know. So we want to be able to fill in our p and q values, so we need to look at the vertex and find out what that is. So remember x value first, so it's going to be 2, and then the y value in this particular one is 1. So that's our vertex. And then we can just pick another point on the graph. So let's do this one because it's kind of nice and easy. So we have 3 in the x and 5 in the y. Okay, so let's use that information. We have a vertex, which is 2, 1, and we have a point, which is 3, 5. Okay, so now we can start using the equation to find out what a is. So if we think about here, instead of f of x, because we're going to be filling in a y value, I'm just going to write down y is equal to a x minus p. So remember, p is right here, which is 2. And we're going to square that, and we're going to add the q value, which is 1. Okay, so I've filled in my vertex points. Now the other thing I can do so that I only have numbers and I can solve for a is I can fill in another point on the graph. So the other point on the graph says that y is equal to 5. So I'm just going to substitute that in. A stays the same. We don't know what that is. That's what we're trying to solve for. X is going to be 3 minus 2, square that, plus 1. Okay, and we end up with 5 is equal to a times by 3 minus 2 is 1 squared. 1 squared is 1 times by a is just a. So a times by 1 squared plus 1. Okay, so basically because this is 1 times by a just stays the same. So now if I want to solve for a, it's going to be a is equal to 5 minus 1. So we can say a equals 4. Okay, now that I know what a is equal to, I can make my general form of the equation here by saying f of x is equal to a, which is 4 for this particular equation, x minus p, so minus 2 squared, and then plus 1. So now I have my quadratic function. Okay, and that's exactly what we're going to do when we're working backwards from the graph. Okay, so just so you know, this part here, I just filled in the equation with the vertex. Equation with vertex. So that part we would have known easily already, and then this is the equation with the point that we selected. Okay, so basically I keep substituting in values there so that we can do this solution. Okay, next question. Find the equation of the following graph. So we have the graph here, and we're actually told f of x equals ax plus 3 squared. So the only thing we need to do to make this a proper equation is have a number value for a there. Okay, so we're going to follow the same exact set of kind of steps. So the vertex of this graph is right here, and we can see that that's at -3 on the x and 0 on the y. And then if we pick a random point, let's say this one here, so the x value is -1 and the y value is -2. Okay, and now we can start looking at solving our values. So we have f of x, which I'm just going to substitute in as y right away, is equal to a, sorry guys, I've got something on my paper there, a, and then x plus 3 squared. Okay, so all I need to do now is substitute in my values for the point here, because the 3 that we had, that offset the vertex, was already included in the equation we were given. So now I just have to put in my point. So the y value for my point was -2 is equal to a times by my x value, which was -1 plus 3 squared. So now I can say -2 is equal to a times by -1 plus 3 is 2, and if I square that, it's 4. So a times by 4. So now I can say a is going to be equal to, I'd have to divide out my 4, so it's going to be -2 over 4. And of course I always want to simplify, so -2 over 4 gets reduced to -1 over 2. Okay, so now I have my lowest possible fraction there. And it's important to be aware of the fact that when you are calculating these types of values and putting them into the formula, generally you don't want to use the decimal, you want to use the exact value, which is the fraction. Okay, if for like a 0.5, it doesn't really matter as much, but when you get into weird like long decimals, you can't put those in, so you want to get used to being able to write those in fraction form. So now we can say that our overall formula is f of x is equal to -1/2 times by x plus 3 squared. Okay, so hopefully that seems relatively straightforward, going the other way. Now the next thing we want to be able to do is determine the number of x-intercepts using a and q. So we want to see how many intercepts we would have. So we have 3 different functions that are given to us, and we basically want to kind of do some visualizing with those. So our first graph is, we want to keep in mind the location of the vertex and the direction of the opening. So we have an a value for this first graph of 1/2. So we want to think, how does that affect the shape of our graph? And then we have a q value here of -7. Okay, so we're going to go through those and answer some questions down here. So for the value of a, for this first one, 0.5, what is a compared to 0? Is it greater than, less than? Well, 0.5 is greater than 0. Right? And it's positive, so it opens which way? Upwards. Okay. Now, what about the value of q? How does q relate to 0? Is it greater than, equal, or less than? Well, with -7, we can see that our value is going to be less than 0. And so that means our vertex is going to be found where? Above or below the x-axis? Well, with a negative value, it's going to be below the x-axis. Okay, and so if we're visualizing this graph, it's opening upwards and it starts below 0. So we're going to have a vertex maybe here, and then the graph can kind of open up. Oops, it's going too narrow. The graph can kind of go up like that, right? And with the 1/2, it's technically going to be wider than a regular x-squared graph. So how many x-intercepts do we have? Well, this graph on this side crosses the x-axis right here, and on this side it crosses the x-axis right there. So we have 2 intercepts. Okay. Next type of graph, we have f of x equals -2 times by x plus 1 squared. So if you'll notice, we have an a value here, a p value here. Do we have a q value? Well, it's not written in, and if it's not written in, technically that means that we're adding 0, right? So actually we can say right away that Q is equal to 0, and so the vertex is going to be on the x-axis. Okay. What about our a value? Well, it's negative and it's 2. So if a is compared to 0, a is less than 0. And that means that our graph is going to open downwards. Okay, so now if we want to visualize the graph, we start at 0, right? Q is on the x-axis, and it's going to open downwards. Okay. The only other thing we need to think about that's not mentioned here is that we have this p-value of +1, right? And what does that tell us? Remember that it's always x minus whatever number. So if it's a plus, that's the reverse. So we need to move left 1, right? So we're going to start out here. It's opening downwards. And what do we have here? It's going to be not wide. Okay, so there's our graph. We can maybe actually put in here like some of our vertexes. This one would have been -7 on the y. So 0, -7. This one here is -1, 0. And how many intercepts do we see? Well, only right at the vertex does it cross the axis, so we only see 1 intercept there. Okay, now the last one here we have f of x is equal to -1/6. So what does that tell us about the value of a? Well, the value of a compared to 0 is less than 0. So that means that we know that it's opening downwards. What does the fraction here tell us? Well, you probably know that it tells us that our graph is going to be wider than normal. Then we have our Q value here is greater than or less than or equal to 0. Well, it's -11, so it's going to be less than. So that means that our vertex is going to be where in relationship to the x-axis? It's going to be below the x-axis. Okay, and so if we want to visualize the graph, we know that let's see, our vertex is going to be at, again, we have a negative here, so that tells us that we're going to move not to the left, but to the right. So our x-coordinate is +5, so let's say maybe right about there, and our y-coordinate is -11, so it's going to be like way down. And we said that our graph is going to open downwards, and with the 1/6, we know that it's going to be quite wide. Now, of course, we get kind of cut off pretty early on here in this graph, but that's okay. So we can put in 5, -11 as our vertex points. How many x-intercepts are we going to have? Well, if our vertex is here and the graph can only go down from there, we're going to have 0 x-intercepts for this graph. Okay, so when you're asked to determine the number of intercepts, this is the kind of thinking that you need to do, is where it will be in relation to the x-axis. So let's try one kind of word problem that integrates a lot of this together. So suppose you have a parabolic archway, so it's just like an arch that has a width of 280 centimeters and a height of 216 centimeters at its highest point above the floor. Okay, so just before we get started here, kind of something to think about here is, this is, if we're going to think about this kind of like a graph, because it tells us right away, write a quadratic function in vertex form that models the shape of this this arch. So what would this component here be right at the middle of the arch? Well, it's going to be the line of symmetry, right? So the axis of symmetry. And so basically that means that on either side of this, if the whole width is 280 centimeters, we want to say 280 divided by 2 gives us 140 centimeters in either direction, right? So now we know kind of like the width of each component here. Okay, so if we were going to sketch this as kind of like a graph, we can kind of do something like this. We can think about the floor as being like the x-axis because that's basically 0. And then our height is going to be, or our vertex is going to be at the top here. So what would be our x value there? Well, let's just kind of arbitrarily make that into 0 because this is how we drew the graph. So it's 0, and then our y is 216. Okay, then we can show that the graph is going to go down. Okay, and what would each of these points be where we have intersects? Because those are going to be important in being able to do our calculations, right? It's always good to have an extra point on the graph to work with so that if you have to calculate A like we've done before, then you'll know a point on the graph. Well, if this is 140 centimeters and we count this as 0, then this point is going to be 140 on the x-axis and 0 on the y-axis. And then, of course, this one going the other way is going to be negative 140 and 0 as well. Okay, so now we have a few points on the graph that we can work with. So if it's asking us to write a quadratic function in the vertex form, then we can do that by solving for a because we already have p and q, right, in our vertex form. And then we can write a proper function. So let's see, what would we do here? We're going to say f of x is equal to, let's do the same thing we did last time. Let's start out by writing it with the values that we know from the vertex. So our a value we don't know, that's an unknown. So ax squared. Well, sorry, we would do x minus p. P is going to be our x value here. So because it's 0, we don't have a p value. So instead of doing bracket x minus something or x plus something, it's just going to be x squared, right? Because there's nothing to add on to it. Then the next thing we're going to do is plus or minus the q value. Well, our q value is positive, a positive y value, so we're going to put in plus, and the value itself is 216. So now we kind of have the beginning formation of our equation, but we also want to solve for a so that we need to substitute in, instead of f of x, we're going to fill in a y value. Y equals ax squared plus 216. Okay, and what is a y value that we know? Well, we could have 0. And just because I still kind of rather work with positives, even though it shouldn't make a difference, I'm going to put in my x value as 140. So it's going to be a times by 140 squared. Okay, plus 216. And so basically that's going to, if I have 0 here, then I want to start isolating my a, so I'm going to move 216 over. So 0 minus 216, negative 216 is equal to a times by 140 squared, which is 19,600. Okay, now if I want to solve for a, I just need to divide that out. So I can say a is equal to negative 216 over 19,600. Okay, now I have a fraction here. If I do this division, so if I go negative 216 divided by 19,600, I end up with a non-repeating decimal, right? Like a long kind of drawn out decimal. And like I mentioned, we don't want to use those in our forms. We want to use the exact value. So keep that in mind as well during tests. If you're asked to write down the exact value, you either need to use a radical or a fraction. Okay, so basically we can reduce this, and basically I think I ended up dividing it by like 6 or 8 or something like that, and the lowest that I ended up getting down to was negative 27 over 2,450. Okay, so that's the simplest form of that. So now if we want to write our function using sorry guys, my microphone cut out. So if we want to write our function using our a value, we're just going to write f of x is equal to a, which was negative 27 over 2,450 times by x squared plus 216. Okay, and that's our overall function. So now there's a little part of me that doesn't love the way this looks with that big fraction there, but it is what it is, and you shouldn't be intimidated by it. Mostly I just don't like it because I feel like it looks kind of messy, but okay, so the next part here is determine the height of the archway at a point that is 50 centimeters from its outer edge. So basically, I kind of wrote in here a little bit of my thinking, which is that if you're 50 centimeters from the outside edge, we already set up here that 140 is your outside edge, right? So if we work with maybe the right side here, for example, 140 would be here, but we're 50 centimeters in from the outside edge. And so basically that's going to be 140 minus 50. So we're going to be at x equals 90. So we can say, like right here, let's say x equals 90. And we're just trying to solve for what is going to be the y value here. So y equals question mark. Okay, so if we want to figure that out, basically all we need to do is substitute in our x value to find the y value. So remember, f of x is the same essentially as y, so we can say y is equal to negative 27 over 2,450 times by x squared, and we just found out that x was 90, so 90 squared, and we want to add 216 to that. Okay, so in your calculator, I basically just did 90 squared times by negative 27 in brackets divided by 2450, close bracket, and then I added my 216. Okay, so now you can see I end up with this decimal, non-repeating decimal, and just be aware, though, that because we're just asked to find the height of the archway, we're not trying to make an equation, so you can use the decimal now. You don't have to use the exact value. So we can say y is equal to 126.73. Okay, so, and that's in centimeters was our units. So now we can say that the function of when x is 90, okay, so, and this is another thing that we haven't really addressed yet, but basically when you fill in your function for a given number, then you can substitute that number in for where the x would be so that we know which specific value you're referring to in this function. F of 90 is equal to 126.73 centimeters is our final answer there. Okay, so that's it for our introduction to quadratic functions in the Vertex form. You guys have an other part of this assignment basically, so the second half to work on. And that is it for today. And let's see, next time, what are we looking at? 3.2, we're going to be looking at, quadratic functions in the standard form, which you probably will recognize from Math 10. So I'll see you then.